Hey guys, today we're going to look at 3D Pythagoras, so finding lengths of diagonals. And we'll start off with a little problem like this, and you might be asked to find the length of A to D here, okay? And to do that, you've got to do a few things. You've kind of got to do two Pythagorean triangles, and the hardest thing is actually visualizing what you're trying to find here. And so you're going from one bottom corner to the top corner of a room. And I will show you on here, which should help you visualize what's going on. So here I've got a room, like we did there, and this one here, I'm going to have, get rid of that. So this one here, we've got, the length here is 5 centimeters, this one here is 4 centimeters, and this one here is 3 centimeters. Okay, so hopefully we've got that visualized. That's our problem I've just made into a 3D thing here. Okay, the first thing we want to do is work out the length of the diagonal from this bottom corner to the back corner over here where the pink is. Okay, and to do that, we need to switch it up like that. And we're going to make a little right angle triangle in the bottom of here, like that. Okay? And so we know that this is 5, this is 4, and so we can use Pythagoras to work out what this diagonal is here. And all I have to do is, on my calculator, I'm going to do 5 squared plus 4 squared. And I'm going to do the square root of that. So I've got the square root of my answer, which is 6.403. So I know back on here that this length here now is 6.4 centimeters. Okay, and so I can go back on to here, and I've worked out that this distance along the bottom here is now 6.4 centimeters. Okay, so now hopefully we can see another right angle triangle. And I'll go back onto here, and what we're going to do is just get rid of this wall here, and same to this one here. We just get rid of that. Now hopefully we can see that this is our problem here, and we found already that this length along here was 6.4 centimeters. I know that this one here is already 3 centimeters, and all I'm trying to find now is this length from down here to up here. And so I've just got another right angle triangle, so I do the square root of 6.4 squared plus 3 squared. Alright, so if I go back on here, I've got my 6 squared plus, what was it, 6.04 squared plus 3 squared equals that, and then I just do the square root of my answer, and my length is 6.74. So back on here, I've just found out that that length there is 6.74. And so if I go back onto my one here, so it's 6.4 squared, this one here is 6.74 now. Okay, hopefully that makes some sense. We're going to look at another example to make sure. So this one, same sort of thing, but we've got slightly different numbers. And so the first thing you need to work out is this length from here to here. And so we've got a right angled triangle like this, and we've got 10 and 8 now. So this is the bird's eye view, and so we do 10 squared plus 8 squared, which equals 164. And then we just find the square root of 164. So back on my calculator, I've got the square root of 164 equals 12.8. So I know that one there is 12.8, and this one here is 12.8 centimeters. And then so next up, I've just got this other triangle here. And so this one I've got 12.8. And this one here is 4, and I've just got to do the same thing. So 12.8 squared plus 4 squared equals plus 4 squared equals that. And then all I have to do is do the square root of 179.84, which equals 13.41. So I know this one here is 13.41, and that's my answer solved, 13.41. So feel free to go and have a look back through there. That program I was using is something called Floor Planner. You can set up a free account. It might help you visualize the 3D problems. Other than that, it's pretty simple. So just remember to first of all find the length of the diagonal on the floor, and then you make another second triangle using that length and the height.